In this video, we're going to cover this idea of independent events. We'll start by introducing the topic and then going through some of the key questions that come up in Saxon exams. For those who don't know me, my name is Chris Onozoni. I've been tutoring for about 2 years now, and I make these videos so that VC students can do the best they can in math methods. With that out of the way, let's get into it. This whole idea about independent events is that the probability of one event occurring has nothing to do with the probability of some other event occurring. Mathematically speaking, we say that the probability of some event A, given that some other event B has occurred, is the same thing as just the probability of that first event A. That is to say that the event B has nothing to do with the event A. Another way to represent this is to say that the intersection between A and B is the same thing as the product of the two individual probabilities of A and B. This is because if you expand out that conditional probability formula, you'll find that you have the intersection divided by the conditional. Now, if you replace the intersection with the product of A and B, you'll find that the probability of B cancels down, leaving you just with the probability of A. So, in summary, those are the two main ways you can prove that events are independent. So, let's try an example. In this case, people were queried about how they tend to spend their free time, whether they listen to music or watch movies. To prove independence, we can use either of the formulas we mentioned earlier. To start with, I'll use the intersection version. The interesting thing here is that the specific elements that you choose don't actually matter. For this example, I'll just contrast male and movies, but it's also just as valid to, for example, do female and music. It doesn't matter what elements you choose. I'll actually plug the results of that other approach at the end. But anyway, first things first, let's find that intersection. So we see that there are 75 males who prefer movies out of a total 700 people that were surveyed. This fraction can be a bit nasty to simplify, so my recommendation is to break down each individual term into its prime factors. From there, you can cancel things down and then just expand out at the end. Having done that, we now need to find the probabilities of male and movies. For male, there are 300 of them out of a total 700 surveyed, and for movies, there were a total of 175 yeses out of 700. All we do from here is multiply the probabilities of male and movies and see if we get the same fraction. And sure enough, we do. That result proves that male and movies are independent events. If we didn't get the same fraction, then these would not be considered independent events. By the way, here's that working out for female and music. Even though the actual fraction at the end was different, the only thing that matters is that both sides of the equation are the same thing. The intersection was the same thing as the product of each individual term. The alternative method of proving independence is to use the conditional probability method. In truth, this only looks different. When you expand out that conditional probability formula, you'll very quickly notice you're still finding the exact same things as earlier. You still need the intersection, and you still need the individual probabilities of that intersection. So, since we've already found each of those terms, I'm just going to borrow the answers from before. From here, we're just going to do a slightly different thing. We're going to divide the intersection by the conditional, and then see if that result is the same thing as the probability of male, which in this case, it is. So the only difference between those two approaches is whether you're doing a multiplication or a division. And just to reiterate, if the probabilities did not match, those events would not be considered independent. We'll see an example of that next. Okay, similar situation here, but this time the numbers are different. And we want to know if regular use of medication is independent of age. So let's get to work. We need to find the intersection, and we need to find the individual probabilities of that intersection. Again, you have that freedom of picking which events you want to contrast. For me, I'll just choose yes and younger than 30. So there were 200 people that both regularly use medication and were younger than 30 out of the total 1,000 surveyed. After simplification, that's a 1 in 5 chance. Now, for the probability of saying yes to regular medication use, there were a total of 600 people who said yes out of the total 1,000 surveyed. After simplification, that's a 3 out of 5 chance. And finally, for the probability of being younger than 30, there were a total of 520 people who said they were younger than 30. So, after dividing that by the 1,000 total people, you get a final probability of 13 out of 25. All we do from here is multiply the two individual probabilities and compare that to the intersection. And when you do that comparison, you'll see very quickly that those are not the same fraction. Hence, these events are not independent. What that means is that regular use of medication does depend in some regard to the age of the person. Sometimes you'll be straight up told that the events are independent. Under these circumstances, you'll need to realise that that is actually one of the key pieces of information for solving the question. In this case, we want to know the probability that a given family has a pet or a car or both. Well, the use of the keyword or implies a union. This is made doubly clear by saying that both options are acceptable. So we'll start off with the union equation, which means we need to know the intersection as well as the individual probabilities. Well, the individual probabilities are already told to us, so that's nice and easy. But when it comes to finding the intersection, we need to work just a little bit harder. This is where the independence comes into play. We know that events are independent if the intersection is the same as the product of the individual events. So all we're going to do here is replace that intersection with the product of those two individual events. And since we already know those probabilities, all we're going to do is multiply them together and then simplify our result. Okay, let's wrap this video up with a tech active question. The whole idea here is not to find the value of the union, but the minimum value of the union. This kind of wording shows up a lot in polynomials, and sure enough, we can absolutely lean into that when it comes to solving this kind of question. So, if you recall from polynomials, if you ever wanted to find the maximum or minimum of a certain thing, you first needed to find an equation that described that thing. We want to find the minimum of a union, hence to start with, we need to find an equation for the union. So we're going to start with the union equation. From there, we're told that the probabilities of A and B add up to give 0.4. So we're going to replace that part of our union equation with 0.4. Now we just need to do the intersection. Once again, these events are independent. Hence, we can replace that intersection with the product of the two individual terms. This is good, but we aren't quite there yet. Again, borrowing from polynomials, we need to get our equation in terms of just a single variable, whereas ours currently has two, since there are two unknown probabilities. We can fix this by going back to the first equation that we were told about. All we do from here is rearrange it to get one of those variables on its own. I'll choose the probability of A, but it doesn't matter which one you choose. This allows us to use substitution to replace the probability of A with its equivalent expression in terms of the probability of B. And having done that, suddenly our union equation only has one unknown in it. Technically speaking, you should also limit your domain of the probability of B, so you don't get nonsense stuff like probabilities that are greater than 1. The good news is this won't actually end up mattering for this kind of question, so I'll just address it at the end. Anyway, if we pay attention to the equation that we have, we'll notice that it's a quadratic. In fact, it's a positive quadratic, since the squared term is positive. This means that the minimum possible value is going to occur at a turning point. To find this turning point, you can use any method that you like for finding turning points. The most widely applicable method is to set derivative equals 0, so that's what I'll do. I'll just make sure to write x instead of PRB in the cas because the cas is expecting a single variable. The syntax is going to be the same whether you use the Casio or the TI Inspire. Anyway, that's going to give us a solution that PRB is equal to 1 out of 5. Now, it's worth doing a quick double check to make sure that that answer makes sense. Is the probability between 0 and 1? And sure enough it is. Well, okay, that probability makes sense, but that's not the answer that we wanted. We wanted to know the minimum of the union. So we're going to take the probability of B that we just found and sub that into our union equation. The result after that is our answer. I mentioned earlier that when you're doing these kinds of questions, you should restrict the domain of your polynomial. And in this case, we can look at the first equation that we were given to achieve this. If you look at the rearranged version of our equation, we can set that right-hand side to be between 0 and 1. When you solve that inequality on the cas, you'll find a valid domain for the probability of B. Just make sure that you cap that lower bound to be 0. That's a good starting point, but the other thing you should make sure of is that the probabilities of the union are also between 0 and 1. So we can sketch our union equation over that domain that you just found and make sure that it is still between 0 and 1, which it is. At this point, we're just splitting hairs though. At the end of the day, the question was still answerable even if you didn't bother doing this. I still want you to be aware of these small details just in case your SAC or exam decides to be mean to you. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.